3 different polarizing filters. So like I understood the idea that it's with the formulas and stuff, but I didn't know how to go about it when there were 3.
Just to use one after another after another.
Yeah, I tried that and it was not right.
That's strange. I don't see the homework. I need the current. This is part 2.
Yeah. Number 10.
Mm-hmm. Well, I guess it's also related to how we read this picture, because it's part of the problem. Initially unpolarized angles, but measured relative to y-axis. So the initial intensity we can set to 100%, of course. And when it travels through the first polarizer, the new intensity will be equal to what?
The original intensity times cosine of theta squared. Like, so the cosine squared of theta. I don't know what the best way to describe that is.
Well, that's why I asked what kind of a light was initially traveling, unpolarized or polarized.
It is unpolarized.
Exactly. And you didn't use this fact, I believe, because what you're saying has a name, the Malicious Law.
Oh dear.
But
sorry, but she hates
okay.
delivery men.
Everybody can learn physics.
Yes.
So this law implies something very specific about the light, and that implication is in this angle. How should it be measured?
Relative to the original. I mean, so if you had already polarized light, it would be relative to that angle of polarization.
You don't answer the question about the angle. All angles, no matter what, have to be measured between 2 directions.
The x and y axis. So
no. Any angle. Any angle is measured between 2 directions. The question is, not angle, between 2 directions. The question is, what directions do you have to use for each specific situation? That depends on the situation. For example, if you have a loop in a magnetic field, how do you measure the angle?
The loop in the magnetic field is the area vector.
Area vector has to be one of the directions, and second is magnetic field, and then you know how to measure the angle. Same rule has to be applied to this angle, because this angle is one of all angles, and any angle has to be measured between 2 directions. So how do you measure this angle?
It would be the initial polarization and the filter, like the angle of polarization.
Well, yeah, the polarization of light, which is basically electric field. Doesn't matter, it always just given to us when we need it. And second, this, what we call transmission axis of a polarizer.
Mm-hmm.
Transmission axis. So these angles, see it says polarizing sheets with polarizing directions, which means transmission axis of this polarizer in that direction.
Mm-hmm.
This is at 35.1 relative to vertical y-axis. This is one direction.
Mm-hmm.
One direction is not enough to measure angle. You need information about the second direction, the direction of the polarization of light
Right.
that is traveling, approaching toward that polarizer. So, can you tell me the direction of polarization of initial light traveling toward the first polarizer?
So it says it's initially unpolarized, though.
So,
What do you
can
mean
you tell me
direction?
the direction?
I mean, towards? Is that what you?
No. Towards
No.
means velocity, yes.
Right.
But that is not, well, velocity points towards, but the direction of polarization is an arrow.
Mm-hmm.
So can you tell me the direction of the polarization of unpolarized light?
Well, no, it's not polarized. Is that?
No, that's the answer. No.
Yeah.
So
Okay.
if you cannot tell the direction of polarization, does it exist in general?
No. Okay.
No, it doesn't exist.
Yeah.
So if this direction doesn't exist, how can you measure this angle?
Right. You can't.
You can't. If you cannot measure this angle, how can you apply this law?
I guess you can't.
You
Yeah.
can't. Well, that's the logic.
Mm-hmm.
What does it mean? If you cannot apply this law and still need to solve a problem, what does it mean?
You have to figure out another way to solve the problem, right?
Well, what is another way? If this doesn't work,
Yeah.
what does it mean? If this equation doesn't work, what does it mean?
And it's I don't know. I mean, that equation right now we can't use it. I mean,
Exactly.
like,
Well,
yeah.
well, you cannot use this equation, but you need to solve a problem. So what does it mean?
Hmm?
What does it mean? How do we solve a problem if this equation doesn't work?
This is
What do we need?
more information and to Google and stuff. That's what I've been doing.
When we need to solve a problem in physics, eventually we
Yeah.
have to write an equation. We have
Yeah.
to write.
Right.
You wrote it.
Mm-hmm.
It didn't work. What does it mean?
To find another equation.
You need another equation. That's exactly what it means.
Right.
That new equation is supposed to be related to unpolarized light.
Yeah.
Unpolarized light traveling through a polarizer.
Mm-hmm.
Have you seen that equation?
I don't think so.
All right. In that case, you should ask. Who could you ask? Who could you ask?
I could ask you.
Exactly. Or
Google.
Google. Who do you prefer?
I mean, I'm here. We come to office hours.
Okay, so you want me to answer. This is the equation. When light, initially unpolarized,
Mm-hmm.
travels through a polarizer, the new intensity is equal to exactly a half of the initial.
Okay.
That's the new equation.
Alrighty.
But that's not all. There is a second very important statement. Light becomes polarized in the direction of the transmission axis, because that's why we call it transmission axis. It only transmits lights in that direction.
Right.
So the new intensity will be a half of the initial, and the new light will be polarized in this direction, the direction of transmission axis.
Mm-hmm.
Okay?
Yes.
Now it is polarized light, and it is approaching to a new polarizer, gets through the new polarizer, and for the new polarizer, we've got the new transmission axis that looks like this. You can see it here. This angle is 20 degrees. And so this blue arrow represents transmission axis of a second polarizer. And this red arrow represents the direction of polarization of light after the first polarizer, but before the second. Can you, well, now, okay. Now you have to choose what equation do you want to use now.
I could use the one with the angle because I could calculate the angle.
Exactly. Because now you know both directions.
Right.
So this is the direction of the polarization of light. This is the direction for transmission axis number 2. You want to apply this law. And what intensity should you write as initial now?
It would be the half of the original intensity, so they're like
just
50 or 0.5 or yeah.
So cosine squared, and now you need to write this angle between these two directions. What number do you want to write?
So our original angle was what, 35.1 degrees? In this original, so I mean it would be 180 minus the sum of those two angles, right? To find the, I don't know how else to describe it. I mean,
well, I understand.
Yeah.
But why would you subtract 180? And so this picture missing an important element because all angles are measured relative to y-axis, and if that element is missing, that's what makes it confusing. Now, this angle is the first number. Well, in my case, it's 35.1. This angle, or this angle is the second number, which is in my case 20.1. So what angle, what number?
I could just use the sum of
you
those.
just need to add them up all together.
Okay.
That will be, in my case, 55.2 degrees. That's it.
Okay.
And now we have to repeat the reasoning. First of all, okay, this will be, what is it? It's 2. The intensity after traveling through the second polarizer. This is what polarizer does, changes intensity, but also what does polarizer do?
Changes the direction.
Yes, so now this light will travel preserving the direction of transmission axis number 2. This is the new direction for the polarization of light. And now it will be traveling through the third polarizer with the third transmission axis directed like this. So what law do you want to apply? With the angle or with 1/2?
With the angle.
Of course, because light already polarized. And if you want to apply this law, well, basically you have to write this intensity from the previous calculation times cosine squared of what angle now?
Transition angle 3 plus transition angle 2.
So transition 3 and transition, yes, that's it.
Okay, that makes sense.
And all problems on polarizers are solved exactly like that. We just have to pay attention because sometimes initial light might be already polarized. In that case, you would have started from the very first equation, of course, if it would have been polarized. But if it's not, this is what you do first.
Okay. All right. Thank you so much.
Sure.
That helped a lot. I think that's it for now.
Well, good. Thank you.
Thank you so much. Take care.
Bye.
Bye.
And how do I say it?